My name is Bella, and I'm going to be going over question 19.1 from the Electrochemistry additional problems. This question states, calculate E naught, delta G, and K for the following disproportionation reaction done at standard conditions. 2 copper plus yields copper 2 plus copper. Your first step is going to be to determine which half reactions are oxidation and reduction. In this case, oxidation is going to be the one losing an electron, so the half reaction will be copper plus yields copper 2 plus 1 electron. Your reduction reaction is going to be the one gaining an electron, so that will be copper plus 1 electron yields copper. To find E naught, the reaction is E naught of the cell equals E naught cathode minus E anode. Your anode is going to be your oxidation reaction, and your cathode value is going to be your reduction reaction. Looking at the table of given electrochemical values, your value for the anode is going to be 0.15 volts, and for the cathode, 0.52 volts. Using this equation, E naught of the cell is found by taking 0.52 voltage minus 0.15 voltage. Your final answer is going to be 0.37 voltage. Because both of the values given are given in two significant figures, your final answer is also going to be two significant figures. Next, we're going to calculate delta G of the cell. Delta G is found by using the equation delta G cell equals negative N times F times E naught of the cell. In this case, N is going to be the number of moles of electrons transferred per copper atom. F is going to be a given value known as Faraday's constant, and that value is 96,485 C per mole. E naught is going to be the value that you found in part A, which is 0.37 voltage. In this case, 1 voltage is equal to 1 joule per C. So in order to cancel out units, you can convert 0.37 voltage to 0.37 joules per C. 1 mole of electron is transferred per copper, so we're going to use 1 as our value for N. Plugging this into the equation, we get delta G equals negative 1 mole times 96,485 coulombs per mole times 0.37 joules per coulomb. You can cancel out the moles and the coulombs in this equation and just be left with joules. Next, by carrying out the multiplication, you're going to get delta G equals negative 35,699.45 joules. This can also be converted to about negative 35.70 kilojoules. Going back to our two significant figures from the first question, your final answer is going to be delta G equals negative 3.6 times 10 to the 1 kilojoules. For the last step of this problem, we're going to calculate K, also known as the equilibrium constant. To solve this problem, we can start by taking an equation that we know. Delta G equals negative R times T times ln K. Rearranging this equation to solve for K, we can get K equals E to the negative delta G over RT. Next, we're going to figure out the values that we do know. R is the gas constant, which we know to be 8.314 joules per mole Kelvin. This equation is done at standard conditions, so the temperature is 298 Kelvin. We calculated delta G in the last problem and found that to be negative 35,699 joules. In this case, we're going to stick with joules because we want our units to cancel out. Next, we're going to plug in all the values that we know. This is going to get us K equals E to the negative 35,699 joules times 8.314 joules per mole Kelvin times 298 K. Multiplying and dividing that out, we're going to get K equals E to the 35,699 divided by 2,477.572. Now, finally solving for K, we're going to get K equals 1,810,049.61. We want that in significant figures of 2 and also using scientific notation. So our final answer is going to be K equals 1.8 times 10 to the 6th. K is a unitless value, so we're okay leaving it with no unit. To wrap things up, we use the equation 2 copper plus yields copper 2 plus copper to find E naught of the cell, delta G, and K. Using E naught of the cell equals E of the cathode minus E of the anode, we found E naught to be 0.37 voltage. Using delta G equals negative N F E cell, we found delta G to be negative 3.6 times 10 to the 1 kilojoules. Using K equals e to the negative delta G over RT, we found K to be 1.8 times 10 to the 6th. Thank you.